Okay, so in this video, I'm going to take you through every exam question that has been asked on transformations of graphs. And like I always say, if you do want to use this document, it is linked in the description. So when you use this document, it's fully hyperlinked, which means each part will click through and take you through to different sections. So for transformations of graphs, I'm not going to actually be teaching you on these kinds of things, but I am going to be just sort of going through the questions. So if you do want to have like the full teachings on this, I have taught this, and there'll be that playlist on my channel homepage for you to look for. Okay, so this first question that we've got here, it says the graph of the curve C with the equation y equals f of x is transformed to give the graph of the curve S with the equation y equals f of minus x minus 3. The point on C with coordinates 7 minus 2 is mapped to the point Q on S. Find the coordinates of Q. So first of all, this thing here, this means that the x coordinate is negated or becomes negative. So this means that x is negated. And the fact that there is a minus 3 at the end means that y is going to have subtract 3 to it. Anything that's inside the brackets is to do with x, anything that's outside the brackets is to do with y. So that means that the x coordinate is going to become negated, so it's minus 7, and the y coordinate is going to be 2 minus 3, because this is the current y coordinate 2, and so we get minus 7 minus 1. So pretty easy for this first one here. We get minus 7 minus 1. Okay, so now we've got for this next one, it's a non-calculated paper. Here is the graph of y equals sine x. On the grid, sketch the graph of y equals sine x minus 2. So this minus 2 that we've got here means that it is going to shift 2 spaces downwards. This is going to shift 2 spaces downwards. It's because it's happening outside of the sine function. It's happening as an after thing, a bit like in that previous question. So this point to begin with is going to move down here. This point at the base is going to move down here. This one is going to go to here, this point will move 2 spaces down to here, and this one will move 2 spaces down to here. And then it's just a matter of trying to draw this as kind of neatly as you can and not worrying too much about it being perfectly accurate, because they're just concerned about the shape and saying that it has shifted 2 spaces down for this. So let's have a look at the answer. Yep, we've got ours in exactly the same place. It was going through here, and now it's going 2 spaces downwards. Okay, this time it's got another non-calculated paper, and it says the graph of y equals f of x is shown on the grid. On the grid, draw the graph with equation y equals f of x plus 1 minus 3. So this thing kind of does the opposite. When it's inside the bracket, it kind of does the opposite of what you think. So the x coordinates are all going to subtract 1, and then this minus 3 means that the y coordinates are all going to subtract 3. So as a vector, what is happening here, as a translation, it means the whole graph is all going to move 1 space to the left and 3 spaces down. So when I try and draw this graph, if I just concentrate on one of these places, it is going to move 1 space to the left and 3 spaces down. Now that I've got the start of that drawing, I actually think I can just draw the whole graph. So it's going to go along here, 2 diagonally, and then this part is going like 3 diagonal spaces up. So it's going to go 3 diagonal spaces up, and then it's going to be going 2 spaces to the left. So every single point has moved 1 to the left and 3 down. It looks like it's going to go 1 to the right and 3 down, but it actually does the opposite of what you expect in there. It then says that point A, which is 2 minus 1, lies on the graph y equals f of x. We can see it right here. When the graph of y of f of x is transformed to the graph with equation y equals minus f of minus x, point A is mapped to point B. Well, this thing here means that the x coordinates are all negated. So whatever the x coordinate is, it's going to flip and become negated. It actually also corresponds to a reflection in the y-axis. So this point A that we've got here, the x coordinate is going to become 2 minus 1. So the coordinate B is going to shift over here, and it's going to become 2, 1 instead. So the coordinates of the point B are just going to be 2, 1. Okay, let's have a look at the answers for this. So the graph, it does say the translation is going to be minus 1, minus 3, and the coordinates of B are 2, 1. Okay, another non-calculator one. This time we're going to be doing some drawing and then also writing an equation. So it says here on the grid above, sketch the graph of y equals f of x minus 2. Now remember, this does the opposite of what you expect. This is going to add 2 onto the x coordinates. In other words, it is going to move the whole graph 2 spaces to the right. So that means that this point at the bottom is now going to be over here, and instead of it crossing at the origin, it's going to cross at 2, and instead of it crossing at 2, it's going to cross at 4. And I guess we can also do some further points. We can say this point up here is going to shift 2 spaces to the right, and this point over here is going to shift 2 spaces to the right. So that when I draw this together, you should see that we get a kind of quadratic that has shifted 2 spaces to the right. Everywhere has shifted 2 spaces to the right. It then says for a 1 marker here, on the grid graph A has been reflected to give graph B. The equation of graph A is y equals g of x. Write down the equation of graph B. So if it is a reflection in the y-axis, this is something you just need to know off by heart. It is that y is equal to g of minus x. That thing inside the brackets means that all the x coordinates are negating. In other words, it's a reflection in the y-axis. So we did get the sketch. Well, the sketch has got all of these bits here, but that is exactly the same as what we were trying to do. And then y equals g of minus x. Okay, on to the summer 2020 paper. It says the graph of the curve with equation y equals f of x is shown on the grid below. On the grid above, sketch the graph of the curve with equation y equals f of minus x. So again, it's that same thing of talking about it being a reflection in the y-axis. In other words, all of the x coordinates are negating. So this point here is going to move to here, so we can tell it's going to start doing like that kind of journey. It's then going to cross through this point, which is over here, and it's going to come down like that. It's then going to bump here and come back up to the top. So we can see we've got a reflection of that line in the y-axis. We're also going to do some now with writing equations. This little box up here gives you some extra information about the question. It says the curve C with equation y equals 5 plus 2x minus x squared, which is this one here, is transformed by a translation to give the curve S, such that the point 1, 6 is mapped to the point 4, 6. And we're going to try and find an equation for S. So if I called this one here f of x, or y equals f of x, this one has moved 4 spaces to the right. Now that would be f of x minus 4, kind of does the opposite of what you're expecting. So if we're saying that y is equal to, this is for the C curve, if we're saying that y is equal to 5 plus 2x minus x squared, the S curve is going to be the same thing, but instead of there being x's, there are going to be x minus 4's in all of these places. So the S curve is going to be 5 plus 2 lots of x minus 4 minus x minus 4 all squared. I'm going to just pull that along so that I've got a little bit more space for this. So I can just put that squared where I want it to be, just to the side like that. Now, it doesn't ask for it to be simplified at all, so we can just leave this exactly as it is, and that will still get us those 2 marks that we've got. So we have the graph drawn, which I can assure you is correct. Why did I say it's 4? All of this is terrible. It's not moved 4 spaces to the right. It's actually only moved 3 spaces to the right. So I'm hoping you were shouting at me with that video. It's moving 3 spaces to the right. So I'm very quickly going to go through and adjust that. Hopefully you were saying, why has he done this wrong? So all of these aren't going to be with a minus 4. They're going to be with a minus 3 instead, because it's moving 3 spaces to the right. So that was me not even be able to do the difference between 1 and 4. Not a very good sign. Okay, we've then got one again with a y equals sine x graph here, and it says using this graph find estimates for all 4 solutions of sine x equals 0.6. Now this is kind of not to do with transformations, but transformations is going to come up in part B and part C. So we're just going to very quickly go through this one. Hopefully this is going to be something you are familiar with. We're going to try and find all 4 solutions to when it is equal to 0.6. Now 0.6 is over here. So I'm actually going to draw a line at 0.6, and we're going to use that to hopefully help us to find out all of the solutions that we have. Now it says find all 4 solutions are between 0 and 720. Interesting. So at this point, there's actually only 2 solutions. There's a solution here, which comes down to this value, and there's a solution here, which comes down to this value. So we've only got 2 solutions, but they've said 4, and I'll explain why that's the case in just a second. So if this is 90, it looks like each of these squares is representing 30. So let's just quickly do some adjustments here. This is 30, this is 60. And if there are 5 squares that represent 30, then each square must represent 6. So I would say that this one, if each square is 6, it looks like it's 1.5 squares. So I would say it's 39 for this part. And then we can do the same kind of logic for this one. Because it's an estimate, it should be okay for us to do this, but I'm going to say it's 180. Well, that's going to therefore be that's going to be 150. And again, it's probably 1.5 squares backwards. So if it's 1.5 squares backwards from this, I'd probably say it's either about 141, something like that. So I'm going to say that this one is 141. It probably should be 1.5 squares backwards. If I actually draw this in a little bit more neatly, you'll see that it is kind of there. So the solutions that we've got so far for x are going to be these ones, which is 39 and 141, but it does something. It says 4 solutions, and because it says the graph goes all the way up to 720, so you have to know that the graph is going to repeat and do that whole process over there. So there are going to be 2 more solutions at this stage here and here. Now, if you know anything about the sine graph, you know that it repeats every 360 degrees. So I can take both of these answers and I can just add 360 to them to get the next ones. So if I add 360 to 39, I get 399 degrees. And then if I also do 360 added on to 141, I would get 501 degrees. So let's see if we've got these right in a second, but we'll do the transformation ones first of all. It then says for part B of the question that the graph of y equals sine x is reflected in the x-axis. So reflections in the x-axis, we know that reflections in the x-axis are written like minus f of x. So that means just putting a minus at the beginning, which means it will be minus sine of x degrees. You don't have to have the degree sign, but we're going to keep it there. And then for part C, here is a graph of y equals f of x. On the grid, draw the graph of y equals f of x minus 2. So that means all of the x coordinates are having 2 added onto them. It kind of does the opposite of what you think. So it's a translation of 2 spaces to the right. So if I move this point 2 spaces to the right, I'm also going to move this point down here 2 spaces to the right. I think the rest I could probably just draw. So those are going to connect. Then there's a little 1 bit at the bottom. And then I'm going to do this line here, which is a diagonal line. It is going to come across like this. So you can see that that whole shape has shifted and moved 2 spaces across. Every single place it's moved 2 spaces across. So they have said 37, 143, 397 and 503, but they do give a pretty wide range. So we said, I think, 39 and 141. So that's definitely fine, and our other answers were inside those gaps as well. Probably would have been easier if it was printed in the kind of large size and I wasn't doing it on my iPad. So that's all of the questions about transformations of graphs. You'll see that they do tend to offer like an easy place to get marks if you just memorize some of what the things that they mean. And if you are planning on doing A-level, these do come up in A-level maths as well. So it's making sure that these are already memorized for you. If you find this helpful, please do like the video, please do subscribe to my channel and share it with some friends.